Hello friends, this is Dr. Shanam Mounty, Assistant Professor in Mathematics, Government First Grade College, Jeevargi, Gulbarga District. As with the Fourier series, we know about the odd and even function of the series that depends upon the intervals 0, 2 pi, 0, 2l, minus L comma L minus pi comma pi. In this video we will go to or we will discuss about the odd and even function which is related to the interval 0 comma 2l. For the function we can say that the Fourier series which is arbitrary period or the function with the period 2 pi or 2l. How we can say that it is a 2l means, see, a function need not always be defined in the interval of the length 2 pi only. When the length of the interval other than 2 pi, we shall denote it as 2l. In general, the interval of length 2l be c, c plus 2l. It is important to note that the sine and cosine function is of the form sine pi x divided by L and cos pi x divided by L are the periodic function of the period 2L. For this, we can justify that the function f of x plus 2L is equal to f of x by taking f of x is equal to sine pi x divided by L, and another function also we can define in terms of the cos, that is g of x is equal to cos pi x divided by L. For the both function we can prove that f of x plus 2l is equal to f of x and g of x plus 2l is equal to g of x. In that case, as we know, the trigonometric series is of the form in the interval c, c plus 2l, that is f of x is equal to a naught divided by 2 plus summation n is equal to 1 to infinity a n cos n pi x divided by L plus summation n is equal to 1 to infinity b n sin n pi x divided by L. If f of x defined in the interval c, c plus 2l satisfies the Dirichlet series of the form f of x is equal to a naught divided by 2 summation n is equal to 1 to infinity a n cos n pi x divided by L plus summation n is equal to 1 to infinity b n sin n pi x divided by L, and it is called the Fourier series of the arbitrary period 2L. In this, we can establish the Euler's formula for the Fourier coefficient in the form of a naught is equal to 1 divided by L integral c to c plus 2l f of x dx. an is equal to 1 divided by L integral c to c plus 2l f of x cos n pi x divided by L into dx, and bn is equal to 1 divided by L integral c to c plus 2l f of x sin n pi x divided by L into dx. Here a naught, an and bn are called the Euler's formulae. If we come from for the even and odd function, for the single valued function, the interval minus L, L, the even function we can define as f of minus x is equal to f of x. For the odd function, f of minus x is equal to minus f of x. For splitting the function, f of x is equal to phi of x for minus L less than x less than 0, and the same function f of x is equal to psi of x for the interval 0 less than x less than L. F of x is even if phi of minus x is equal to psi of x, and f of x is odd if phi of minus x is equal to minus psi of x. For the example, if we go for the example regarding the even and odd function for the single valued, we can say that let the example it is f of x is equal to x. If you put x is equal to minus x, then the above function it tends to f of minus x is equal to minus 6, and that is equal to minus f of x. Thus f of x is equal to x is called the odd function. In the same manner, for the example for the even function, which is f of x is equal to s to the power of 4, whatever the value of x, it will be even. In the same, if we come for the trigonometric function f of x is equal to sin x, which is an example for the odd function. If we go for the even function in terms of the trigonometric, it is an example for the cos, that is phi of x is equal to minus cos x and psi of x is equal to cos x. Psi of minus x is equal to minus of cos minus x, that is equal to minus cos s, because we know that cos of minus theta is equal to cos theta only, because already we know that it is even. So that is equal to minus of psi x. Therefore, phi of minus x is equal to minus psi x, which is an odd function. For the property of the definite integral, integral minus L to L f of x dx is equal to 0 if the function is odd, and the same interval minus L to L f of x dx is equal to 2 times of the integral 0 to L f of x dx if f of x is even. In the same manner, for the interval 0 to 2L, the function which is defined as 0 to L and L to 0 minus L to 0 and L to 2L. In that case, the function we can define as it is 0 if f of 2L minus x is equal to minus f of x, and the same function it is 2 times of the integral 0 to L f of x dx if f of 2L minus x is equal to plus f of x. For the property 2, the product of two even function and the two odd function is always even, whereas the product of even and odd function is always odd. This we know that. Using that, we can define the formula for even function in the interval minus L to L. That the case 1, if f of x is even function, then the Fourier coefficient of the Fourier series, that is a0 is equal to 1 divided by L integral minus L to L f of x dx, where f of x is a function of even, that is equal to 2 divided by L integral 0 to L f of x dx. So that is the a0 value equal to 2 divided by L integral 0 to L f of x dx. In the same manner, if we come for the another coefficient term, that is a an, 1 divided by L is integral minus L to L f of x cos n pi x divided by L into dx. For the given, we already know that cos is even, and also given that f of x is even. Using the property, if the product of two function is even, if the product contains two even function, we know that the the obtained value is also even. So for that, the an value tends to 2 divided by L integral 0 to L f of x cos n pi x divided by L into dx. The another coefficient of the Fourier series, that is a bn. This bn is 0 because f of x is even, and bn which contains sine function also, and we know that sine is odd. The product of two even and odd function which is odd. If the product is odd, then we know that the value of the function is 0. So that is bn is equal to 0. Therefore, after knowing the values of a0, an and bn, the Fourier series which turned as f of x is equal to a0 divided by 2 plus summation n is equal to 1 to infinity an cos n pi x divided by l. For the second case, if the function is odd, if this function is odd, the a0 is 0 because f of x is odd. Already they are given in the splitting terms. And an which is contained two function, and in that one is odd function and another one is even function. Using the property, the product of one is odd and one is even, the function value which is 0, that means which is odd. If the function is odd, we know that the value is 0. According to that, an is also 0. That means if the function is odd, then their Fourier series, if it contains the even and odd function, a coefficient of the Fourier series, their a0 and an are 0. If we come for the third value, that is bn, which contains the function f of x as well as the sin x. We know that the function is odd, and also we know that the sign is also odd. Using the property, product of two odd function is even. So that means the bn value is equal to 2 divided by l integral 0 to l f of x sin n pi x divided by l into dx. So that is the Fourier series which contains only the bn term because the function f of x is odd. First, for that we should know that if the function is even, only a0 and an are present in the Fourier series. If the function is odd, then the series which contains only the bn terms. And these are the some references that are used to derive the Fourier series which contains the Euler's functions if in the case of odd and even in the interval minus L to L. Thank you.